Hi everybody, this is day 3 of the semester 1 final exam for geometry. Okay, so this first question asks us to determine the slope of the line that contains the points -2, 1, and 0, 6. So for this we're going to use our slope formula. Sorry, that was a little hard to read, which looks like this. y2 minus y1 over x2 minus x1. So I always recommend labeling your coordinates, and then all you have to do is plug in the numbers and simplify. So y2 is 6, y1 is 1, x2 is 0, y2 is -2, so I'm going to say plus 2. So always look out for times when you're going to be subtracting a negative, because of course that turns into a plus sign. And now all we need to do is simplify. So 6 minus 1 is 5, 0 plus 2 is 2. Our slope, which is always represented by the variable m, is 5 over 2. All right, here you are given 4 points, and you're asked to use the slopes to check the relation between line segments AB and CD. So whenever you're asked to do something like this, you're going to use the slopes to determine if the lines are parallel or perpendicular, or maybe neither. So two lines are parallel if they have the same exact slope, and two lines are perpendicular if they have opposite reciprocal slopes. And of course, opposite meaning one is positive, one is negative, and then reciprocal meaning your numerator and denominator are flipped. So we're going to find the slopes of the two separate line segments and then compare them. So let's start by finding the slope of AB using our same slope formula that we just talked about. So we have y2 minus y1 over x2 minus x1. So I can simplify, and we have 1 over 1, which of course is just 1. So that's the slope of line segment AB. Now let's find the slope of line segment CD. So here we have y2 is 2 minus y1. So you'll notice that y1 is negative. So remember, subtracting a negative becomes a positive. And then here we have 3 minus -2, so 3 plus 2. So let's simplify. We end up with 5 over 5, which is also 1. So you'll notice that line segments AB and CD have the same slope, which means that the two lines are parallel. There you have it. Okay, this says, in the figure, assume that A and B are parallel and line N and M are parallel. So that's going to be important for us in determining these angle relationships. So they tell us the values for angle 9, which is right here, and angle 15. Now, if you look at these pictures, what we have is we have a transversal cutting two parallel lines. So we actually don't even need that other half of the figure. So if you look at the relationship between angle 9 and angle 15, you can see that those two angles are alternate exterior angles. And we know that alternate exterior angles, when you have two parallel lines cut by a transversal, are always going to be congruent. So if angle 9 is congruent to angle 15, I can create an equation that says 6x minus 5 equals 10x minus 19. And now all we have to do is solve. So I'm going to subtract x from both sides. and then I'm going to add 19 to both sides. So we end up with 4x equals 14. Divide by 4. Sorry about that. So x equals 7 over 2, which is 14 over 4. So let me show in that last step. So when you have something like this where you can't divide it out evenly, but both the numerator and the denominator are divisible by the same thing, we always need to simplify. And if you look back at the question, they're asking you to find the value of x, so we're done. So now we're going to review all of those angle relationships that we talked about with two lines and a transversal. So the four that are really important to know are corresponding, alternate exterior, alternate interior, and consecutive interior. So we're going to name at least one pair of each of them from the figure. So let's start with corresponding. Corresponding means that they are in the same relative location. So if you look at this, I like to kind of think of them as houses. So we have one house on the bottom and one house on the top. And there's 4 rooms. There's a room downstairs on the right, downstairs on the left, upstairs on the left, upstairs on the right. So we're trying to find the two numbers that are essentially in the same room. So we could say angle 1 goes with angle 6, 2 goes with 5, 3 goes with 8, or 4 goes with 7. Any of those are acceptable. So I'll say angle 4 and angle 7. They are both in the same relative location. They're downstairs on the right. Okay, let's talk about alternate exterior. Alternate means that they're going to be on opposite sides of your transversal, and exterior means that they're going to be on the outside of your parallel lines. So these are your exterior angles. So we're going to pick two that are opposite. So it's either 2 and 7 or 1 and 8. So either of those pairs are acceptable. I'll say angle 2 and angle 7. Alternate interior, alternate again, meaning on opposite sides of the transversal. This time interior means inside your parallel lines. So 3, 4, 5, and 6 are all interior angles. So we have to pick opposite ones. So 3 and 6 or 4 and 5. Either pair works. So I'll say angle 4 and angle 5. Last, consecutive interior. Consecutive is going to mean on the same side of the transversal. And interior, again, means inside. So we're going to pick from the same 4 interior angles, but now we're working on the same side. So it's either 3 and 5 or 4 and 6. So we'll say angle 4 and angle 6. So now we're going to talk about what we know about those angle relationships. So this is going to be really useful when we're solving for a bigger problem. And of course, this is only going to be when we have parallel lines. So I'm going to add in with parallel lines. So this is really nice because 3 of them are going to have the same property. So corresponding angles with parallel lines are always going to be congruent. So remember that symbol means congruent, which means equal. Alternate exterior angles are always going to be congruent. Alternate interior angles are also going to be congruent. Consecutive interior ones are the only ones that are different. These angles are going to be supplementary, which means that they add up to 180 degrees. So that's the one to watch out for. That's the only one that's different. Okay, so now let's try using some of these properties. Here it says in the prompt that line M is parallel to line N. So we're going to add in these little arrows which show that they are parallel. So these, once again, mean parallel. And now that we know that they're parallel, we can use those properties we just talked about. So there's actually two different ways you can go about this problem. One way is you can look at the two parallel lines and this transversal. So if I look at it with that transversal, I can see that I have two consecutive interior angles. So I'm actually adding up 22 and x. So I know that this and this, these are consecutive interior. And we know that consecutive interior angles are supplementary, meaning that they add up to 180. So I can make a nice little equation that says 22 plus x plus 78 equals 180. Now we just need to solve, so we get x plus 100 equals 180. So x will equal 80 degrees because it's an angle. Now there is a different way we can go about solving this problem if that didn't really jump out at you. Let me erase this line. So we can also use this other line as our transversal. So if we do that and I'm looking at my angles, I notice that this angle right here and this angle are alternate interior angles and are therefore congruent. So we start using alternate interior angles, which are congruent, and then we can look inside this triangle. So hopefully you remember that the angles of a triangle should add up to 180. So that was called the triangle sum theorem. The sum of the angles, once again, should be 180 degrees. So then we can use that fact to create an equation. So we have 22 plus x plus 78 equals 180. So you'll notice that we end up with the exact same equation that we have above. So either way you do it, you're going to end up doing about the same amount of work and you're going to get exactly the same answer. So whatever jumps out at you is what you should do. All right, in this picture, this is the same figure we used before. So we have the two sets of parallel lines. They tell us that angle 13 is 110 degrees, and they want to know what angle 4 is. So there's no direct relationship between 13 and 4, but we can kind of work our way over. So I can look at angle 13 and I can say, okay, angle 13 must be congruent to angle 5, which is right here, because they are corresponding angles. So that means that angle 5 is also equal to 110 degrees. Now when I look at the relationship between angles 4 and 5, I notice that those two angles are going to be supplementary because they are consecutive interior. So I can say that angle 4 plus angle 5, I switched them around, should equal 180 because consecutive interior angles are always going to be supplementary when we're working with parallel lines. So now I can create my little equation. We know that angle 5 is 110. So we can solve for angle 4, which becomes 70 degrees. So remember, just kind of work your way over. You don't have to go straight here. You can say, okay, 13 and 7 are alternate interior, so they're congruent. 5 and 7 are vertical. 13 is also congruent to 11, which is congruent to 9, which is congruent to 1, and then we have a linear pair. So there's a lot of different ways that you can kind of work your way over. So now we're going to practice naming the different relationships that we talked about earlier by looking at the different pairs. So let's start with angle 3 and angle 6. So you can see that they're both inside the parallel lines but on opposite sides of your transversal. So these are going to be alternate interior angles. Now let's look at angles 1 and 8. They are on the outsides of your parallel lines, but on opposite sides of your transversal. So those are going to be alternate exterior angles. 4 and 7, you'll notice that they're both in the same relative location. They're both downstairs on the right, downstairs on the right, so that will be corresponding. Now let's look at angles 3 and 5. So they're both inside the parallel lines, but on the same side of the transversal. So that's the consecutive interior angles. Now we can look at 5 and 7. This one is not specific to these type of problems. We've talked about it before in the review. These are called vertical angles, which we also know are parallel. And last, or not parallel, I'm sorry, we know that they are going to be congruent. And last, let's look at angles 1 and 4. So if you look at 1 and 4, you'll notice that they actually form a straight line. So we can call those a linear pair. And we know that linear pairs are supplementary because all straight lines should add up to 180 degrees. Okay, so now we're going to try a different type of problem. So in this, we have a triangle, and then we have a line extending, and then an angle on the outside. So we're going to use the exterior angle theorem. So this theorem stated that the exterior angle should equal the sum, which is addition, of the remote interior angles. And remote, remember, means far away. So 153 is our exterior angle. It's on the outside of our triangle. So you'll notice that we're going to use the two interior angles that are not touching 153. So that's how we know that they are remote. So remember, we can't use this angle for this theorem. We have to use the ones that are not touching our exterior angle. So let's set up an equation using the exterior angle theorem. So the exterior angle is equal to the sum, so I'm going to add the two remote interior angles. So there's my equation. So now we just need to solve. So we have 3x, zoom out a little bit, plus 6. So we're going to subtract 6 from both sides. We get 147 equals 3x. And now we're going to divide by 3. So you could do a little long division on the side, and you should end up with 49. So x equals 49. Let's check the problem. They did ask us to find the value of x, so that means that we are done. All right, we got two more. So this says, in the figure, which theorem can be used to prove that triangle ABC is congruent to triangle XYZ? So here we're going to revisit our triangle congruence theorems. So we really had 4 options here. So this is the information that you need to be given to conclude that the triangles are congruent. So one of them was side, side, side. So if you know that all 3 corresponding sides are congruent, you can conclude that the 2 triangles are congruent. And then we have side, angle, side. And it must be in that order. And then the last 2 were angle, side, angle. So I'm not going to write those out because it's just ASA, angle, side, angle. And then angle, angle, side. So if it's not one of those, then we can't conclude that those 2 triangles are congruent. So let's look at what we're given. We have a side here, an angle here, and a side. And if you mark it up, it helps to see the order that it's given in, because they all have to be right next to each other. So this would be side, angle, side. So just make sure it's one of those 4 options. Remember, there's no such thing as side, side, angle. So make sure you have this list either memorized or written down so you can use it on the final. Okay, last problem. This says draw a right triangle, triangle ABC, where B is the right angle. So let's start with that. So let's first revisit what it means to be a right angle. A right angle is just a 90-degree angle. So that means that a right triangle is just a triangle with a 90-degree angle. So we can draw that. They end up looking like this. And the way that you can show that they are 90 degrees is using that box. That little box, remember, means 90 degrees. So they said that angle B is the right angle. And for A and C, it doesn't matter which one is which. So it says, name the side length that must be the longest. So I want to remind you guys that there is a relationship between the angles and the sides. So the largest angle is always opposite of the longest side. And of course, that means that the smallest angle is always going to be opposite the shortest side. So if we have a 90-degree angle, we know that these other 2 angles must be acute. So we know that this angle, angle B, is our largest angle. Well, that means that if we look opposite of angle B, we're going to find the longest side. So that side is line segment CA, or you could name it AC. Either way is perfectly correct. So just remember there is that relationship between the order of the angles and the order of the sides. All right, that's all for today. Thank you for watching.